We'll finish this example really quickly. Part B here is what we're doing now. We'll have a Riemann sum. Part B says, about how far does the bobsled travel in the first 10 seconds? Well, that's a way of saying distance, right? Or displacement. Displacement or distance. We don't have any negative area here. Doesn't appear. So we're going to have distance and displacement be the same thing. And so it says use a right Riemann sum with 10 subintervals. So again, and this is one reason why we really don't need to see the graph of our function in order to be able to find these Riemann sums. So this is basically saying starting at 0 and stopping at 10, accumulate the area in the plane trapped between the velocity function and the horizontal axis, and we're going to use a Riemann sum to approximate that. So let's look at our widths. We have 10 subintervals, right? So we're going to break this up into 10 different intervals. So we start at our right endpoint, we subtract our left endpoint, and we divide by the number of rectangles we're going to have. So our widths for each of these rectangles are going to be 1. And our heights, we don't have to plug them into the function because our heights, our speed, is already given here for us. So we just need those heights. Now, this is important. Don't forget this. We're going to use right Riemann sums. So for every rectangle, here's one rectangle. It starts at 0 and stops at 1. There's one rectangle. The height is going to come from the upper right-hand corner of that rectangle because this is a right Riemann sum. So our heights are going to be height 1 is 6, height 2 is 12, height 3 is 25, height 4 is 40, and so on. And we add up all of those heights that are really easy to find because they're right there on our table. So there is the distance, or how far the bobsled traveled in the first 10 seconds. And this is miles according to the units from our velocity function. Again, it's a free response question. I don't have to clean that up. I don't have to add it. I'm not even going to work on it anymore. I'm just going to walk away. And this tells the AP reader that I understand that how far it traveled is the accumulated area over the interval trapped in between the velocity function and the horizontal axis, and that I'm using an approximation because a Riemann sum is an approximation. And so we see this a whole lot, so make sure that you could do this. So this is the last video. It's a very short one, but I wanted to finish up that example because it's technically the only part of the example that had to do with the definite integral. So make sure you understand the notation. Make sure you understand that a Riemann sum is an approximation, and that this notation of and by itself would be the exact area trapped in the plane, but we're using a Riemann sum, so it's an approximation. So come next time ready to do some Riemann sum work, some approximations of areas in the plane, but using the definite integral to tell us how to do it and over what interval. So come next time ready to do some homework.